Hello there, I am Dr. C.N. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. Hello everyone, thank you for joining me once again on my channel. Today we are going to start a new series which will be looking at calculating and determining correlation coefficient of relationship between two variables. When we intend to find a relationship between two variables, we call that bivariate analysis. And one tool that's used to find that relationship is what we call correlation. So remember, relationship has to do with correlation, or correlation has to do with relationship of two variables. Now, the degree of that relationship, which also shows the direction of the relationship, is denoted by a small letter r. And it's the value you're going to get in determining correlation. It's between -1 and +1. So it might be negative, it might be positive, but it's not usually up to 1. When there's a perfect relationship, then you have a 1, but most times relationships are never perfect. So we're looking at determining correlation coefficient of two variables. Now, the variables can be in different ways. We want to find relationship between wages and performance. We want to find relationship between price and demand. We want to find relationship between income and demand. We want to find relationship between attitude, if it can be quantified, and work performance in different situation. You want to find relationship between birth rate and whatever kind of variable you want to find in any field. So you use correlation analysis to determine that. Now, one challenge many students have most of the times is how do they remember the variables you need to determine in a table, and then the formula that looks quite long. How do they remember where to pick what and what to remember? That's what we're going to do in today's video. So please follow me as we look at this classical case on the board, and at the end we will interpret the value that we get. So let's look at what we have on our workboard today. Here you can see we have correlation analysis, and we have example 1. The price of a certain commodity and the quantity supplied by a distributor are given below. Here we have price, and then we have the quantity supplied. The question we have is to calculate the correlation coefficient between price and quantity. We want to find the relationship and the direction of the relationship, the strength of the relationship and the direction of the relationship, and that's denoted by R. Now, what we do first of all is that we need to find three basic relationship between X and Y. In this case, we will note price as X and the quantity supplied as Y, being the other variable. So here, let's draw our table. First of all, we start with representing X, right? Solution here, and then we have X value, the value of X here, and then we draw this, and then we have the value of Y. So X we have 8, 10, 15, 17, 20, 22, 24, and then 25. As you can see, for Y we have 25, 30, 32, 35, 37, 40, 42, and then we have 45. So these are the values of X and Y. We now need to find three things, very important relationship. And the first one, you remember, is to find the product of X and Y. That's the first thing you find. You find the product of X and Y. And so let's do that together. Please follow me along. I want to find the product of X and Y, so you multiply this against this one. So 8 times 25, that gives us 200. 10 times 30, that gives us 300. 15 times 32, that gives us 480. Trust you're following me. 17 times 35, that gives us 595. 20 times 37, that gives us 740. 22 times 40, that gives us 880. 24 times 42, that gives us 1008. And then 25 times 45 will give us 1125. All right, that's what we have here. The next thing we look for is we want to find the square of X. The square of X. That's the next thing you look for. We just need to find the product of X and Y, the square of X, and the square of Y. Those are the three columns that we will create apart from X and Y. So the square of X is to have X squared. In your calculator, you will have to look for 8. You have 8, then exponential 2. Look for this sign. This is exponential 2. That's what you look for. So 8 squared is 64. 10 squared is 100. 15 squared is 225. 17 squared is 289. 20 squared is 400. 22 squared is 484. 24 squared is 574. 76, beg your pardon. That's 76 here. Okay. Then 25 squared is 625. So that we'll look for. Then the next one, we now get Y squared. We square Y. Now, square of Y, that is this column, we square Y. The first one, 25 squared is 625. The next one, 30 squared is 900. 32 squared is 1024. The next one, which is 35 squared, is 1225. The next one, 37 squared, is 1369. 40 squared is 1600. 42 squared is 1764. And 45 squared is 2025. So after determining this, we find the summation of each of these columns. We find the summation of each of these columns. And if you add up the value of X, what you have is 141. If you add up the values in the Y column, that gives you 286. If you add up the columns in X and Y, you have 5,328. add up the columns in your y in the x squared column. You have 2,763, and then the y square column, you have 10,532. That's what we have. So that will have. Now we need to put in all these values in the correlation coefficient formula. And the correlation coefficient formula is given as R. Please look up very closely to this, R, and then that will be N being the number of values that you have. Now the summation of x and y, the summation of the product of x and y minus the summation of x times the summation of y. So we just pull this, which is this value, and then summation of x and summation of y divided by the square root. We have a long square root to deal with, divided by n summation x squared minus summation x all squared, close the brackets, times n summation y squared minus summation y all squared, and close the brackets. So from what you're saying, you realize that we have one part of this equation having the x's and one part of the equation having the y's. So to remember, you have n, this big value here, the one at the middle, you pick this one at the middle, minus the product of the ones on the left, then the square root of the n value again, and you pick the summation x squared minus the one on the left squared for x, and then you pick n again, the summation y squared minus the one on the right. So that's what you use to remember the formula. So let's put in these values as they need to be. What is our n? Well, our n is the number of elements that we have. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8. So 8 is n times what do we have as summation. Let me move to this side. What do we have as summation xy? We have this, that is 5, 3, 2, 8. Then we have minus summation x is 141 times 286. That's summation y. Divided by, we have our square root long like that. So we have 8 again into summation x squared. This is summation x squared here. Summation x squared, that is 2763 minus summation x, this one, that is summation x all squared. So we have minus 141 and squared. Okay, 141 squared. We close the bracket. Multiplied by 8 into summation y squared, which is 10,532 minus summation y. This summation y, that's 286 all squared. I will close the bracket. So this is what we are dealing with now. So that the answer we have, if we multiply this through, we are going to have 42624 minus the product of these two will give us 40,326 divided by, when we do this times this, that's 8 times 2, 763. What we have is going to be, let me see, put the square root here. It's going to be 22104 minus 19881, close the brackets, multiplied by, this one will give us 84256 minus 81796. So this will give us this. Now let's go on further. This value, you have 42,624 minus 40,326. That will give us 2,298 divided by the square root of 2223 multiplied by 2460. So that's what we have. Now we can shift this here to give us 2298 divided by the square root of, if we multiply this through, we're going to get 54688580, and then we further move on to having 2298 divided by, we find the square root of this, that will give us 2338.49. And the answer, when you find the difference between, the ratio of this over this, what we're going to have as our R, that is the relationship, the correlation relationship, the correlation coefficient is going to give us 0.89. Now take note that for any correlation, your denominator, which is the one underneath, should be greater than your numerator, as you can see on this side. So you have 2228 over 2338.49, and this is our correlation coefficient here. This shows that there is a positive and very strong relationship between price and quantity supply. This is strong relationship. Now for space, let me move up here to looking at what we call the coefficient of determination. The coefficient of determination, that is the R squared. That's, we find the square of the coefficient, the correlation coefficient, and this coefficient of determination shows the ratio of the explained variation in the total variation. That where the relationship between the two is showing when you give up all the other unexplained variable. This gives you the real thing, the real relationship between them. So when you remove all the other things, so the square of this will give us, you find that, and the square of this will give us 0.96. The square of R, when you have this, so the square of R will give us 0.96. So what you just do is, so whenever you have R value, you just find the square of R. So this is the solution to this question on correlation coefficient. Please make sure you go through this video again, take note of the formula, and look at the steps that we've taken carefully to go through so that we don't miss out any of the figures that we are dealing with. Thank you.